Hey everyone, welcome. This is Alan Schimmel, Editor-in-Chief of Security Boulevard, DevOps.com, and Container Journal. And thanks for joining us on another webinar today. Today's webinar is entitled Inside an AWS, Amazon Web Service, Breach Investigation. And it's actually a kind of under the kimono peek into the intel from actual breaches on AWS with Stack's security team. And Stack is today's sponsor, so thank you very much to them for sponsoring what should be a good security webinar with some good look at real-life AWS breach situations. Before we get started on the webinar, let me quickly go over our GoToWebinar control panel. We have set aside time for questions today, and within your control panel, which for most of you is on the right-hand side of your screen, right corner of your screen, you'll see a section marked questions. If you click the arrow there or caret so it's downward facing, it should expand. And you'll see that you're able to type your questions in there in real time. And what's nice about doing is once you type your question in, it's queued, it's preserved here. We'll be able to get to it at the appropriate time. We'll be able to answer your questions. You don't have to worry about remembering what your question is. You don't have to worry about the mad rush at the end of the webinar to get your question in. So please, I encourage you, type your question in there in the beginning, and we can go from there. Beyond questions, though, for our webinar panel or guest, if you're having technical issues, maybe your audio is a little choppy or the slides are not advancing, you'll notice a section down at the bottom of your control panel marked chat. And if you expand that, you'll see you're able to chat and put questions and so forth in there. We have engineers standing by. If you have an issue, but you're still able to type into the chat section, please do so, and we will do our best to make sure that we try to make your experience as good as possible here on this webinar. So chat for technical questions, question section they might be of a technical nature, but for questions for our presenter today. And with that out of the way, let's turn now to our topic. As I said, today's webinar sponsored by Stack, and it's Inside an AWS Breach Investigation. Let me introduce you to our presenter. If we can go to the next slide, please. So today's presenter is none other than Sam Bisbee. Sam is Chief Security Officer at Stack. And Sam, welcome.
Thank you very much.
Great. Sam, I'm gonna turn it over to you here. And I'm interested in this myself, so I'm looking forward to learning something.
Excellent. Thank you very much. Well, I appreciate everybody jumping on the webinar today with us. As mentioned, I'm Sam Bisbee. I'm the Chief Security Officer over here at Stack. And we're going to be walking through kind of growing trends in AWS sophistication in bad actor activity. One of the great things about kind of being on the security team at a security vendor like Stack is that we're effectively treated and act as though we are the cloud security team for our customers. And in some cases, we are the only security team for our customers. So we have this really interesting role of both providing tools and services to our customers, as well as kind of building that close relationship with them, helping them through various incidents, breaches, and overall helping them look at their data to make sense of it, whether that be a reactive measure because they've been breached, or a proactive measure helping them understand how to de-risk their environment over time. So we're going to use that knowledge set here to talk about that growing trend. And in the next 30 minutes or so, we'll be walking through how bad actors have become more sophisticated in attacking production AWS environments, leveraging AWS functionality to hide and extend their attacks. What's interesting is that while the majority of the media and vendors are talking about S3 bucket misconfigurations, it seems like there's one in the news every other week, and it's kind of hilarious from our perspective because our PR team keeps saying, hey, can we respond to this? And legitimately, it feels like it's happening every other day. So, it's continuing to be an issue for some companies. As an industry and as kind of a security community, we must look beyond those simple hygiene misconfiguration problems. As companies that are investing in cloud security look to tackle those harder breaches. This is kind of the as ever, blue teams are being forced to mature and up-level their sophistication as well. That's no different than what happened in on-prem data centers, what's happened with laptops and endpoints, is the kind of Sisyphean task that all blue teams take on. We have to constantly up-level ourselves as actors are up-leveling as well. So quick note, as I mentioned, we are basing this analysis on observed attacks, both successful and unsuccessful attacks in ThreatStack's customer base from 2016 to present. And that's really where we saw that sophistication grow. I want to be clear though, we are not discussing a single case or breach, and we have changed some details to protect those customers' confidentiality without impacting the quality of the analysis or intel. Right? This is possible because ThreatStack's agent plus agentless technology gives us both AWS and CloudTrail visibility, which we put through the same IDS engine that processes our agent data, where we're monitoring for process execution, network activity, user behavior, file integrity monitoring with file system events, all that really deep enriched host level visibility. That's running through the same IDS engine as CloudTrail and other AWS data, so we can put this full picture together, taking an agent plus agentless approach, and then analyzing that data across all of our customers and extracting these patterns, as well as working with them. All right, so just to underline, we're not discussing a single observed customer breach, and some small technical details or significant details have been modified to protect those customers' confidentiality without impacting the intel that we're discussing here today. I do want to level set a little bit for those kind of entering this who might be a little bit more green when it comes to AWS. And that's not a bad thing. We work with a lot of customers where security teams don't even have read-only access to the AWS console or environment. And they've been completely locked out by kind of engineering and operations who migrated to the cloud before security teams did. So the kind of level of maturity and understanding of AWS and kind of those mental principles are kind of all over the place, whether you're in security or in ops or call yourself DevOps, right? So as we've been previously or kind of preaching for years, AWS console and API access is the equivalent of putting your physical data center control plane on the internet. So you lose the security benefits of that control plane being offline. You can't really change this. And while there are kind of, some tricks to reduce the surface area of those AWS APIs that allow you to configure and manage your AWS services, those tricks are not complete and they're easily misconfigured, right? The other thing that's key to remember is that access key, you can specify source IP address policies on it. So, a lot of conversations are around, hey, we've got this access key, it keeps getting compromised, and that allows people to make authenticated, legitimate requests against our AWS APIs to manage those services. AWS, launched a great feature that allows you to say that access key is only allowed to work from these source IP addresses. But that type of a control is often misunderstood in security teams, especially kind of the more traditional network security teams, because they feel like it creates effectively a firewall policy for their entire AWS infrastructure in those APIs. But it doesn't. Those whitelists are applied at that atomic access key level. So that's a great example where that's a really great kind of trick or control that is often misunderstood and does not kind of apply in the traditional method. So the overall philosophical mind shift that security teams have to go through is, that VMware management console, that F5 big IP appliance console, whatever those consoles were that traditionally were required physical data center access. Imagine all of those consoles are effectively available out on the street corner and anybody can walk up to them and try and log into them. That's the new security model that we're operating in for this infrastructure control plane. And therefore, the way that we defend it really needs to change. I won't spend much time on, taxonomy of breaches and different types of breaches, but especially in the context of this conversation of rising sophistication of actors, it's important to remember the distinction between opportunistic breaches and persistent breaches. Opportunistic breaches are happening constantly. They leverage automation, and we all have to deal with them. They're the base threat model, actor, and techniques for any online system, whether it's hosted in AWS, on-prem, in a physical data center, another cloud provider like Azure. It really does not matter. If you are online, you are constantly getting scanned and attacked by these opportunistic botnets. And, even if attribution were easy, which it's not, and it's often kind of a unnecessary activity for the 99% of us operating online, those botnets are often commoditized and are actually being rented out to other people. So you can go online, rent a botnet, have it scan through the AWS IP address space, and just see what servers are out there and available and vulnerable. That's the vast majority of the kind of malicious traffic that the internet is seeing at any given time. And the objective of that might simply just be to extend that botnet and grow it so that you can rent it out at a higher price point because you've got more nodes in it, right? So the objectives could be, very simplistic. They just want to run EC2 on your credit card and on your AWS bill to kind of get better ROI on their botnet. They might want to do cryptojacking and so on. Whereas persistent actors, they want something that your organization has specifically, and they're willing to increase their investment and leverage manual attack techniques to achieve that objective, in addition to automation. But the key is you have something that they want, and it's probably extended beyond the kind of lower sensitivity things like spinning up EC2 on your credit card. That might not be as interesting. There are lower investment ways of achieving that, given the kind of overall low hygiene of people running in the cloud because of how easy it is to do that. So they're probably looking for a medium to high sensitivity objective. Hopefully you know what that is, because as a security team, you've kind of looked within your company and around your environment and said, what are the things of value that people might want to get a hold of? Those are the types of actors that we're largely going to be discussing in here, right? Those opportunistic breaches and botnets, we are going to increasingly see them exhibit the types of behaviors that we're discussing today, because there's this natural evolutionary cycle of, as new techniques and tools are adopted over time, they start to show up in these commoditized exploit kits, botnets, and so on. And so that's just kind of the constant shifting evolution and why blue teams need to keep moving. And before we kind of talk about where the sophistication is growing to, we should probably remember where it came from and where kind of most AWS leverage breaches started. Other than simple misconfiguration-based breaches, such as leaving your S3 bucket open to the internet, which that is a problem, but that's not a problem unique to AWS, because any IT tool, any ops tool, any piece of technology can be misconfigured. So we're kind of wiping that class of problem out. But when we look at the AWS leveraged attacks that weren't misconfig related or directly related, all AWS leveraged breaches typically started and ended with credential theft. User and password, that was popular, but it kind of fell out of favor in attackers due to MFA adoption, and as that tooling for MFA became easier. And to that, I would give a kind of a security community and industry shout out to the teams at Duo and YubiKey for the phenomenal tooling services that they put together to make that so much easier for teams to deploy. So given the kind of username, password, credentials were now more typically being combined with MFA, though we haven't seen that be perfectly implemented everywhere, access keys became a much more juicy target for attackers, because access keys are complete credential set, and are typically leveraged in automation and tooling, and therefore teams are not including MFA with those access keys. They're not requiring MFA for that access key to work when you're authenticating into an AWS API. This is compounded by those API keys typically living on a developer or operations employee's laptop, accidentally getting uploaded to GitHub or Pastebin or some other service, or simply being stolen and vacuumed up by malware launching into a corporate environment and picking up credentials off of laptops, right? So kind of regardless of how it happened, fundamentally, these were credential theft problems. And yes, there was some persistence that came off of that, right? They would see, okay, what permissions does this access key have? Can I create other access keys or other accounts so that if my kind of initial credential theft is detected, I have a credential to fall back on, a kind of quote backdoor credential. One of my kind of standard examples for how this was so impactful. So back in 2014, CodeSpaces was a kind of, it was a Valley startup. I believe they were in the Valley. Their entire mission was to back up source code and archival for companies. What was interesting was back in 2014, even before many people were talking about these types of breaches, their AWS console and infrastructure was ransomed to them, where an individual gained access to their credentials, went in, and sent them an email requesting Bitcoin in return for access back to their services. When the CodeSpaces team attempted to regain control of that environment, and they took those credentials back, they did not realize that the actor had gone in and created other access keys and other credentials in case that happened. Once that actor realized that they'd been locked out and that the CodeSpaces team was attempting to regain control, they logged in with those kind of backdoor credentials and started to delete EBS volumes, RDS instances, S3 buckets, i.e. all the customer data that we're backing up. And the CodeSpaces CEO was forced to post a public letter basically saying, we're a backup company. We failed to do that for you. We've lost all your data. We're working with customers to transition data out, and we're returning money to investors. If you're not familiar with the CodeSpaces case study, I highly recommend that you go do a quick Google and look it up. But that was really kind of the traditional methodology, minimal AWS service use outside of the core traditional services, IAM, EC2, and S3. And then all that activity was really focused on kind of base S3 access and maybe launching EC2 servers and environments to kind of extend that botnet and some maybe, security group configuration. What the ThreatStack team began observing in kind of mid to late 2016 and what really gained momentum was that pattern was changing, right? Attackers were learning the complexities of IAM. And when I say the complexities of IAM and AWS, I often like to joke that, I'm the chief security officer of a cloud security company, and I can barely understand IAM at times. It's just a naturally complex API and way of describing what services and users are allowed to access systems in AWS. So it's just standard kind of misconfigs and misunderstanding of what's possible in there, right? So we saw them learning and leveraging those complexities to their benefit and doing more with EC2. And that really gained momentum in 2017. And we saw it being leveraged by both opportunistic and persistent attackers. The more sophisticated actors began to chain that kind of base activity with manual steps, as well as leveraging little-known features. And it's important to remember, these are features in AWS, not vulnerabilities, and any feature in any tool in any service can always be misused at any point from a security point of view. But those little-known features were being leveraged by attackers in AWS. For example, EC2 have IAM roles. Most people think of IAM as pure access management of users into that environment, but those EC2 servers also have roles and can be configured for IAM, and that's how you can grant an EC2 instance access and permission to different managed AWS services like RDS, S3, and so on. right? So simply by compromising a host in an environment, you are therefore gaining a foothold up into the AWS control plane. The second, and what's really forgotten in most places, is that the EC2 metadata service that's hard-coded on every instance. And that's kind of, curl HTTP 169.254, 169.254. That metadata service is an HTTP RESTful API hard-coded on every EC2 instance. This is how, for example, an application for the business gets credentials to read and write data in S3, configure DNS in Route 53, and so on. It's also leveraged by pretty much every piece of DevOps tooling that you can run into. Chef is using it, Sensu's using it, Puppet, Ansible, whatever. All these systems are using that metadata IP to know more about the local instance that they're configuring and what they can do. So actors also began to realize that they could launch EC2 instances anywhere in the network topology, right? So not only can I, if I gain access to an EC2 instance, do I have access to the metadata and credentials for that instance, but I can launch that instance anywhere in the network topology that I want, because most people are not restricting that access on EC2 launch. And that allows them to teleport deep into the layered network defenses by launching an EC2 instance with a set of host-based commands that will execute as soon as the instance launches. So typically, what you'll do is, let's say you have a standard 3-tier network topology. You've got your external web-facing servers, you've got your internal API servers, and then you've got your internal databases. And you've done a really good job creating separate security zones, firewalls between them, and data can only flow certain ways. And you've really nailed it from that perspective. That's not as valuable when, if I steal an access key that has the ability to launch an EC2 instance, I can go ahead and launch that EC2 instance in that ring 0 database tier into that subnet inside that same fire security group config, and I can feed it commands in this kind of how it launches, and those commands are malicious, and those are going to phone back home to my attack infrastructure, and typically we'll either pull more malware from that attack infrastructure to extend my botnet, or I could just send a reverse shell. So now I've got shell level access or root level access on a rogue EC2 instance that I've launched anywhere in your network topology that I want, right? And so that really starts to break down those traditional network security controls that assume that if two servers are allowed to talk to each other by the firewall, that they can kind of trust each other. And that's really not the case. It was never the case on the physical on-prem data center. We just had stronger compensating controls to decrease the likelihood of that happening, kind of that server under the desk problem. But now we've really lost that control in these types of AWS environments. And the kind of tricks that you can play to lock that down are often misconfigured, misunderstood, or misapplied. All right. And so since software is written to, trust those network connections that the firewall lets through, this can shorten a complex multi-hop network attack chain to a single hop, right? So that's kind of the rising sophistication that we've seen, where these actors, they're leveraging the AWS APIs to actually initiate the breaches, but also to hide those breaches and even to exfil data directly, which we'll talk about toward the end here.
Hey, Sam.
Yes, sir.
Alan Schimmel here. Sam, we've had a whole bunch of people join on since we originally got kicked things off at the top of the hour. And I just want to remind people that we have set aside time for questions at the end of the webinar today, in the last 10, 15 minutes or so. And so if you use your question section in your GoToWebinar control panel, guys, we'll queue them up in there so there's not a mad rush at the end. So please feel free. I'm sure a lot of what you're showing, Sam, is stimulating questions in people's minds. So just a reminder, and I'm sorry for the intrusion. Go ahead.
No, perfect. Thank you very much. And so that, perfect time for that segue, because, we're now going to look at what one of these sophisticated attacks looks like, right? So we're going to kind of go step by step through a network diagram that kind of lays out what a kind of standard kill chain or attack chain looks like that leverages these more sophisticated techniques and really starts to combine both the AWS leverage piece of the attack chain, as well as then coupling those and combining those with more traditional network attacks and how they kind of switch back and forth between those different techniques. Right? So step one is kind of going back to that traditional model where you having credential theft from a laptop, a hosted source code system like GitHub, though, I will say that the GitHub security team has done phenomenal work when they saw this kind of trend arise, where they've been scanning through repositories and proactively alerting individuals and teams that, hey, it looks like you have credentials in your GitHub repository, regardless of whether it's public or private, right? And then there were also open source tools available to do that as well. So, the communities where these credentials are often getting mis-uploaded and mis-shared, those teams are doing a phenomenal job to try and crack down and reduce that. But it's still happening. At the end of the day, it's a user arbitrary file upload site. It's just fancy with Git, paste bin, whatever, and then also malware landing onto corporate environments and vacuuming up credentials, right? But fundamentally, that access key is stolen, regardless where it's stolen from. A commoditized opportunistic threat would just kind of load that into their botnet and start their attacks in kind of that automated fashion. But whether it's opportunistic or that persistent, more sophisticated actor, their next step is to perform AWS persistence. And this goes back to that code spaces breach example, where now that I have an access key, I want to know what IAM permissions does it actually have. So kind of what's the attack surface area that's now available to me that I'm authenticated. And then can I go in and can I create more access keys? Can I create temporary credentials? Can I assume rollover to another user? How can I start to effectively move laterally within AWS IAM to persist and kind of entangle in there so that if that access key is detected by the security team as being compromised and they remove it, they might be less likely to notice the rest of my behavior, either because they're not monitoring, they're not using a tool like ThreatStack, or they just have CloudTrail completely misconfigured, or they're not looking at any of that data. Now, the next step, and again, this could be an unsophisticated actor extending their botnet, or that more sophisticated actor establishing a beachhead in your LAN. But with that access key, I probably have the ability to launch an EC2 instance. And I say probably because not all teams configure access keys the same way, and a lot of teams are doing the good job of, requiring that their instances are launched and configured through tools like Terraform and other pieces of automation. But let's assume that that access key is not configured and scoped correctly, because to be honest, over 90% of them are not properly scoped in environments. Or that Terraform or that build and automation infrastructure, that might have been compromised, and the attackers might be initiating a truly sophisticated and complex campaign against this organization, where they compromise the supporting automation infrastructure to grab that access key and move on. On the security team here, we like to joke that continuous integration and deployment, that these are wonderful DevOps tools, and that they are also the most efficient malware distribution methods in any environment. So always be going back and looking at that automation infrastructure to make sure it's secured, just as secure as you've locked down production. Right, so now I've launched this EC2 instance into the LAN. It's on the network. I have root on it. I was able to control how it was configured and deployed. And now I could either have that host install my malware or extend my botnet, or it's doing a reverse shell, and now I have manual access and I can start to move laterally through that LAN, right? And that's where network persistence occurs, right? Now that I'm in, I'm starting to move across that environment. And we're effectively looking at traditional network movement now, where I'm going through, I'm looking at what services are out there, can I access them, are there available exploits, and you're doing much more traditional kill chain. One of the unique properties, though, and where we see these kind of sophisticated actors, they're leveraging AWS, they're starting to realize that my objective might be back up inside AWS. It might be RDS, it might be an S3 bucket, Dynamo, who knows? But fundamentally, my objective is back up there. So at every network hop that I perform, I'm hitting that local EC2 metadata service at 169.254.169.254, and I'm pulling that JSON and I'm looking, do I have the IAM permissions that I want into my objective? So the unique property there is that I'm not necessarily looking to escalate privileges. I'm not necessarily looking to access files on the file system or perform traditional data theft techniques, though I could be, but I'm actually going after what's up in AWS, right? So I'm just checking that metadata API that's available to all users on that Linux or Windows box. So once I get to the end of this chain and I finally find that EC2 instance that has the access that I want, I leverage that EC2 instance's IAM configuration, and I can take actions directly on the RDS instance. Now, we're going to kind of pause here and talk about how could that data actually be exfilled, right? One, and kind of the most simple, is that I could just copy and paste it, right? Oftentimes, teams are assuming that an actor wants all of their data. You know, they want a full database dump, they want all the user credentials, they might want, terabytes worth of, pre-release TV show or movie content, whatever. And those cases are much easier to detect because the volume of data and time that it requires to exfil that data. So that dwell time is longer and therefore it's easier to detect. However, that's not always the case. And oftentimes we've seen compromises where an actor is just looking for effectively a row in a database table. And it's a small enough amount of content that they can literally just copy and paste it right out of their terminal on their screen. And that's not going to fire any kind of data loss prevention or detection tools. I could also kind of exfil it back out through that chain of EC2 compromised hosts in that environment. I could just exfil it through there. But that might be a little bit more noisy because you might have network monitoring in place, looking at, spikes in data traffic. You might be writing the threat stack agent on those instances where we're seeing, wow, those are weird commands. And why is, somebody r-syncing files when that never happens? But the third and kind of, most interesting data exfil technique in RDS is that you can exfil data directly through AWS APIs and services, right? So that RDS instance, maybe I don't have all the access that I want, but that IAM policy was misconfigured, so I can actually initiate an RDS snapshot backup to an S3 bucket of my choice or that I created and that I have complete access to from the outside. And so now I can just download your RDS database backup directly from that S3 bucket. Another fun one is maybe I don't have access to the RDS instance, but I have access to the S3 bucket where you have your backups. Now I could possibly rehydrate that RDS backup into a new RDS instance that I launched. And when I launch it, I set the root password on it. So now it doesn't matter kind of what your application level, SQL schema permissions are, because I've got a root account in that MySQL or Postgres instance, and I can query all the data I want from that rehydrate backup. Or I just reconfigure that S3 backup and download the backup directly, right? So these are all different ways that I can pull data directly through AWS services, or replicate your RDS instance to another MySQL instance that I'm running in my attack infrastructure. I can move that data out directly through the AWS managed services. That's not going to fire the majority of your traditional data loss and kind of network monitoring tooling because it's completely hidden. And this is where, monitoring CloudTrail and treating CloudTrail data effectively as equivalent of host level IDS data becomes so important because you're able to put that chain together and realize when that behavior is happening. Right. So as we're kind of winding down here, I'm sure that, as Ellen mentioned, there's a bunch of questions. We'll be getting to them, but there's a lot going on in this presentation, right? And, we'll open up to questions, and there's going to be more material here on the next slide for you to follow up on. We haven't been able to kind of deep dive into every little detail. But there's a few things that I want to make sure that you walk away with. The first is that traditional network security assumes actors want to escalate privileges within the network or within the host, or move laterally through hosts. And that assumption and that kind of attacker behavior must be extended to include AWS itself when you're doing the modeling and you're defining your detection strategy. So if you're assuming that users want to move laterally through your network and escalate privileges, redefine your definition of network to include AWS services and APIs, because it's effectively one large cloud operating system at this point. That AWS instance is not just in a silo like it used to be on-prem. They're much more tightly coupled from a trust and security point of view than we're used to in traditional on-prem data centers. The second is that as a result, monitoring only one aspect isn't sufficient. There have traditionally been a lot of arguments that detection is feasible with a pure agentless tool set. And I think, as you can see from this, that this is false, because if we go back to this network diagram, if all I was doing was an agentless approach monitoring my AWS assets in CloudTrail, that's good, but it's not enough to detect the entire right half of this diagram. And that's a critical component because the dwell time in that LAN could potentially be much longer than the dwell time up in the AWS APIs. And there's a lot more investment required down in that network attack. So you have a far better chance of detecting them at that stage before they've found the EC2 instance that has the access that they need, right? So while ideally you're detecting and catching them when they're first using that access key or coming in through IAM, setting permissions, trying to do those base level AWS compromise steps, you have to be watching for them starting to use that to work their way down into your network and move laterally. Otherwise, you're losing one of the longest dwell times and easiest places to catch them. And to combine kind of the last two bullets here, the third and fourth bullets, data exfil could be as simple as copying and pasting a single database table row, or as sophisticated as exfiltrating that data directly through AWS services to circumvent traditional DLP tools, right? So you can't just assume that you can look at bytes transferred on a network interface or look at flow data and assume that you're going to catch everything there, right? It just doesn't work that way anymore. Not to mention that because you're working in a kind of software-only environment, and when you look at that network flow, it's probably going to be encrypted because we're in the post-Snowden era and everybody's, applying network level encryption, whether they need to or not in AWS environments. And second, you don't know what the actual software is doing. There's plenty of legitimate database traffic that looks weird or spikes and falls out of standard deviations. And that could be completely legitimate, and you don't know what the actual source was and what the actual destination was. Because the actual source and destination is not IP addresses or servers, the processes and the software and the users running on those systems. So you need that full context, and it's available to you now. So we're going to move on to questions here. I'm sure that there are plenty. For more information, just follow this URL. We posted a bunch of content there, and it's also going to give you ways to reach out to us if you're looking for more information. If you're one of our customers, I want to thank you for being a ThreatStack customer and trusting us and joining us on this briefing. And if you want more information, please just reach out to your account team. Follow this URL and get the information that way. But please also reach out to your account team, and they can work with you or put you in touch with us. All right, so now, as I extend the questions area, first question is, you mentioned there's a way to limit scope of AWS API keys, say to being used from internal networks, but I can't find anything on that in AWS documentation. I'd be curious to do this. So great question. I don't have the specific documentation up in front of me, but if you Google for something effective of like AWS access key IP whitelist or source address, or you just go into the policy configuration for an access key, down in there, and AWS documentation loves to bury information, you're going to find the link, but it's basically you're giving a JSON array of IP addresses that are allowed to be the source IP. Next question is, Sam, how effective are the best practices from AWS and even Center for Internet Security, or CIS? Are these false protectors? So that's a great question. I'm not going to say that they're false protectors. I'm going to say that, like any set of security standards, as soon as they're written, they're in atrophy. And I think a lot of those standards are assuming, or really any compliance standard, whether you're talking about PCI, CIS benchmarks, they're attempting to predict what actors are going to do. And they're attempting to give you a complete set of overlapping controls that de-risks their predictions. That's great, and that's important for people as a starting point, but that's not going to protect you as the attacker's sophistication grows. There's also fundamentally going to be opinions and philosophies in there that you need to sit down and determine whether or not they map to how you operate. I'll give you an example. The Threat Stack tool, we have a feature called Config Audit that goes in and scans through your AWS assets and sees whether or not they're configured according to CIS benchmarks. There was a very, we'll call it spirited conversation when we were designing that product feature to determine whether or not we should be driving towards CIS benchmarks or kind of quote best practices, because we didn't completely agree as a security team or as a security company with all those CIS benchmarks. One of the ones that I always point to is that CIS benchmarks is continuing to enforce the behavior of rotating credentials based on the calendar policy. I have never been a fan of that, and I was very glad to see NIST come out with a publication on access and memorized secrets, basically saying forcing users to rotate credentials reinforces negative security behavior. And this is something that we've always known because people will create, my password Q1 2018. And then when you force me to do it again in 90 days, I'm going to create my password Q2 2018, right? And so you create these insecure behaviors. But with kind of the rise of MFA and how easy and cheap it is, 4 years ago when we were building Threat Stack and we had zero revenue, a couple beta customers, and we hadn't launched yet, and there was, maybe 4 of us who were on the tech team, we had YubiKeys and Duo for MFA to get onto the VPN and jump host at all these different stages because it was so cheap. We had no revenue, but we were buying physical hardware tokens because it was pennies on the dollar, or, effectively tens of dollars for us to do that at that time. The cost of doing it so low, it dramatically increases your security. And this point is if you combine a highly secure password with an MFA and you don't force users to do unnatural things like remember a brand new highly secure passphrase every 90 days, that's where the magic really happens, right? So those are examples where there's a lot of good in those best practices and frameworks like CIS. I recommend for teams that do not speak or know security, it's usually best to go and apply those fairly directly. But you have to remember that that's a starting point. That's going to kind of get you to maybe level 1, level 2 maturity. There's tons of road past that, and it's not going to ensure that you're keeping up with latest trends, right? So you kind of have to apply them accordingly. There's another question in here. What's the advice for SSH key handling? Something like FoxPass is fine. So, SSH key handling and kind of access management into any environment, we could spend half a day discussing that. I won't prescribe kind of what a best practice is because it depends highly on how your system is being built and how you're managing access across your environment. But I will take a moment to kind of describe how we do it here at Threat Stack. So the base kind of access model to Threat Stack's production environment, and this base model has effectively been there since pre-revenue to today, where we're very much post-revenue. has fundamentally been the same, where a user must access the VPN. That VPN access is with per user credentials and per user certificate. We moved all of that down onto actually YubiKeys on a secure element, so we got them off the laptop onto a tamper-proof dedicated device. You VPN from literally anywhere in the world. Our office network, we treat it as a functional equivalent of a Starbucks network. There's nothing special about it. So you access that VPN from anywhere with a per user certificate and passphrase, putting you onto the DMZ. From there, you can only hit one kind of internal dashboard, which again requires additional layers of auth-N and auth-Z, or you can only SSH to a single jump host. That SSH to that jump host is managed again with per user SSH keys and YubiKey tap for MFA, and the passphrase with the SSH key, and then that meters your access to that jump host. The backing infrastructure for all this, from the jump host, you can SSH to different boxes depending on the role that you have and the access controls that are in place and the sensitivity of that machine that you're moving on to. All of this is being managed by a combination of LDAP, Vault, AWS IAM, Duo, OpenSSH, and so on. So, it's a very kind of complex set of tools that we had to build, given that we were building this at a time when all of this wasn't canned for you. But now there's AWS has launched some services that help you kind of do this in their ecosystem a lot more easily without kind of wiring together multiple tools. If you reach out to us, I'm sure that we'd be happy to kind of talk you through kind of more specifics given your environment. But yeah, that's just kind of how we approach it here at ThreatStack. We like to assume that anybody's accessing our production environment from anywhere. And as a result, we basically highly distrust everybody at kind of every step of that access. Next question is, could guard duty alone detect this attack? So for those who aren't familiar, guard duty is a AWS monitoring service for security. It's much more of a kind of traditional black box network IDS approach where they're really looking at network traffic and trying to piece together more kind of standard attack signatures from the network layer. And so from our point of view at ThreatStack, it's just another point of view into that infrastructure. And we like when AWS launches more points of view because over time, we either, integrate with them in the customer's SIM or we integrate them directly into our platform. And from our general point of view, more points of view and visibility into an environment, it's all good. And it levels up our insight as well as our customers. That being said, guard duty does not provide sufficient context. It's kind of a secondary detect and forensic mechanism in my personal point of view, where it's not giving you enough information to determine whether an alert is a false positive. Something like saying, hey, there was a network scan. Well, that's not very helpful. It's not giving me enough information. And it's even less useful given that kind of, quote, teleport EC2 launch paradigm where with that access key, I could launch that AWS rogue EC2 instance anywhere in your network topology, depending on how it's set up. And then my rogue server is kind of sitting right next to your database server, and I can start making application layer connections to it. Or maybe I launch it into your API tier, where that entire tier is firewall permitted to talk to that, MySQL instance or Cassandra cluster or whatever. And that's going to look like normal network traffic, right? Because there's an API, it looks like an API server talking to a database server. If you're successful for any definition of successful, you're probably seeing that network traffic constantly. And guard duty might be able to pick up on some interesting pieces in there, but again, it's not going to give you that full context. This gets even more complicated and even harder to operationalize when you're implementing microservices or service-oriented architectures. especially if that architecture is sitting on top of a tool set like Kubernetes, where all those different containers are all sitting on top of that single EC2 host. And so kind of those standard network paradigms and flows and segments, all of that's kind of broken down and muddied. And net flow level detect and data can be helpful, especially kind of post-forensic view of what happened there. But it's probably not going to be your initial detect point. In the meantime, to detect, and certainly in the meantime to know, are going to be really bad with a tool like that. And that's why it's an extremely powerful tool when you combine it with CloudTrail visibility, AWS managed service visibility, and that host visibility from the EC2 instance itself, and what's the software running in there, what are users doing, and if that network flow goes into that box and GuardDuty tells you about it, you need to know, well, what software actually accepted that connection? What did it do with that connection? And if I can see the other side of it, what piece of software launched that network connection? Is that normal? And all those different types of questions. Another question here, how do containers kind of impact this type of attack chain? So containers are an interesting problem in general. Generally speaking, there's a lot of FUD around containers where people say that they're not secure. Some people say that they're perfectly secure. There are ways of configuring containers, whether you're doing vanilla Docker or on Kubernetes or EKS on managed service with AWS or the kind of equivalents over in Google. There are ways of securely configuring them. But the point is, in containers, they're meant to kind of be Lego bricks where you are combining a lot of the security profiles and segmentation, isolation, security controls that we used to rely on at the VM level and the hypervisor level. Containers don't have that natively because they're not meant to. They're one Lego brick in the overall picture of how you're running this environment. So you have to effectively go in, understand what your isolation and security requirements are, and then build those profiles into a container. And you can get effectively the same level of isolation with containers that you can with VMs. It's just very hard. Taking that out of it and kind of looking at containers in this overall attack chain that we went through today, I'll make the more general point that containers add abstraction, right? So you've got the physical and kind of the data center layer kind of up through the hypervisor, and AWS owns that. And AWS is highly incentivized to ensure that nobody can compromise that, and that the isolation and confidentiality and kind of that provenance of that layer is really rock solid, because if it's not, then they go out of business, right? That's a fundamental security tenet. But kind of everything above that stack, to their shared security model, that's on you. So the more things that you layer on top of that, the more code paths there are, and therefore the more potential bugs there are, and therefore the more vulnerabilities that your security team and your ops team are owning. So if I've layered Kubernetes and containers and all these things on top of a base EC2 instance, I own the security of all those code paths. But if I'm just running, a Debian package with a very basic service daemon, just kind of raw on an EC2 instance, the abstraction is decreased, the complexity is decreased, there's less bugs, so therefore detection and prevention fundamentally get easier. Again, it's not that containers are insecure, it's just that they add more complexity and therefore it's harder to secure. Managed services like EKS, where AWS is taking over more and more responsibility for the running of that infrastructure, that might kind of defer some of that concern for you, where you're owning less and less of those code paths. And with that, I really want to thank everybody for coming out today and joining us. There were a bunch of there were tens and tens of questions, and that's phenomenal. And I wish I could have gotten to all of them. I really appreciate it. Please reach out to us. I'd be happy to kind of talk through your questions, as well as, our team would love to do so as well.
Sam, it's Alan. We do have a record of these questions. We'll forward them to you along with the people who asked them. So if you want to reach out, more than welcome to. So
Awesome.
that'll
And
work.
so feel free to do that. Also feel free, at ThreatStack on Twitter. I'm at SBISBEE, Bisbee on Twitter. Feel free to reach out to us directly that way. Reach out to, the sales teams or your account team here at ThreatStack. Everybody, this is why we're here. We're happy to help you. And kind of final note, we like to say that, security takes a village. So please reach out. We're happy to help.
Great. Sam, thanks for a great webinar, man. I think it was really right on point. And, from the amount of questions, obviously people really were interested in the subject. Maybe we'll have to do another one in the near future. Cool. Thanks for coming. Hey, everyone. Thank you for joining us. This is Alan Schimmel for Security Boulevard, DevOps.com, and Container Journal. Thanks for attending another webinar. We do these a couple times a week. We'd love to see you at another one soon. If you're on our mailing list, you'll get notified. If not, just check out our sites. We have some great webinars coming up. Thanks very much to our friends at ThreatStack for sponsoring today's webinar. And we'll call it a day from here, everyone. Have a great day. See you soon on another webinar. Bye-bye.